Here is the Executive Vice President of Aerojet General Corporation, Mr. William E. Zisch.
Our look into the first 20 years in the life of Aerojet General Corporation must start with the company's heritage, the time before the beginning, around 1940, when a small group of rocket enthusiasts, whose names were Summerfield, Molina, Foreman, and Parsons, came together at Caltech to pursue their almost mystic vocation, rocketry. This group was united in purpose in the Galset Project No. 1 under the far-sighted leadership of Dr. Theodore von Kármàn.
I am very glad to have the occasion to talk to you about the time as the Aerojet General Corporation, or more exactly, at the time the Aerojet Engineering Corporation was formed. Because, of course, this event is very near to my heart, and my experiences before and my experiences after that maybe have some interest as far the history of rocketry and the history of spaceflight in the United States is concerned. Now, as I started to organize that, it was really Hap Arnold, General Arnold, who was helpful. Now, what we started to do at Caltech, for which was an immediate application, was the assisted takeoff.
Assisted takeoff rockets, JATO rockets, were in fact developed and built in those early days at Caltech. Small though they were, they did work, as was proved in actual aircraft testing. Involved in that early manufacture was Fred Miller, and flight tests were performed by then Captain Homer Boushey.
The aircrew flight tests were conducted with units made at Caltech, and they were 15 seconds duration and 25 pounds thrust.
Before initiating work on a larger-sized JATO rocket, it was considered necessary to verify theory by actual tests with aircraft. And since the size and thrust of the small rocket motors was quite modest, the smallest available airplane was selected for tests. Accordingly, an air-coupe-type airplane was fitted with racks under each wing to hold the solid propellant rockets, 6 on each side, giving a total JATO thrust of about 600 pounds. At March Field, we received every help, and the Cal-SIT group, as the Caltech group was known in those days, immediately began preparations for the tests at March Field.
Oh, they were real spectacular, quite spectacular in the takeoff, the angle of takeoff. But as soon as the units terminated, why, the plane would just quit climbing right there.
Work on JATO rockets, Galset Project No. 1, continued until 1942, when World War II brought about a requirement for JATO in quantity.
Then, in the beginning of the 40s, the war started, and the question came, who can do the production in first line of JATO? And at that time, I think it was Molina who came to me and said that they believe, he and the other boys too, that for the production it would be the best to make an industrial company. The Aerojet Engineering Corporation was incorporated on March 20, 1942. I think the tremendous capital was $1,250 There were 5 with $250 each. And I was elected as president. The incorporation was made by Andrew G. Haley, whom I knew as lawyer.
Aerojet was formed. As the summer of 1942 passed, Dr. von Kármàn became convinced that his administrative duties were taking up valuable time which he felt was needed for technical guidance and research.
So I talked with my friends and asked them whether they agree if we ask Haley to be president. Well, they said yes. So Haley came, and I became then chairman of the board. This happened in September 23rd, 1942.
At about the same time, another group interested in rockets was forming under Navy contract at Annapolis. Most of these people subsequently became a part of Aerojet II. The Navy at Annapolis, having more than a passing interest in our progress, sent Marine test pilot Bill Gore west.
And having contacted the Jet Propulsion Lab, GALSIT project, at Caltech, at about the time that Aerojet Engineering Corporation was formed, Bill House and I came out to California in an SBD to test the first 8AS 200. These tests were so successful that later developments brought about the 5AS 1000, 10AS 1000, 12AS 1000, 14AS 1000, which was the one produced in great quantity as far as solid JATOs were concerned for the war.
In those days, of course, we were located in Pasadena in the old Hudson building.
In what used to be what was actually the garage. We had the offices in the showroom. Then, in the automobile agency, you have the showroom. Then you go through a door into the garage, service garage. Set up the production line and built them. All the testing was done at Azusa. We had what we called, what Eddie Behan insisted on calling the proving grounds.
When I entered the gate and got to my assigned place, I couldn't believe that that's really where we work. You see, it was very close to the test facility. It was a temporary shack.
I was taken on a tour to see this reputed proving grounds at Azusa. And I can truthfully say now that as I witnessed my first rocket firing, my reaction was one of incredulence that this couldn't possibly be, and I was not sure whether I should call back to Indianapolis directly or wait till that evening to advise my wife and 2 children, with a third one expected, to stay where they are, and I'd be back in the Midwest by the first train.
Toward the end of the 3rd year of war, production was increasing, and Aerojet became interested in additional projects.
I remained chairman of the board and director, member of the board of director, till 1944, October, 26th of October.
And a short time afterwards, we purchased the facilities at the Azusa plant and moved our headquarters from the Pasadena out to the Azusa plant.
Things progressed very well indeed until the war ended and the government sent us a telegram terminating all our contracts and putting us out of business. 1947 saw some diversification with the creation of the Facilities Division under Ben Rose, which we know now as Atron.
But I think the first thing that we had a job to enter the space age building program. And to build a space age program, we called it then, designing and building the experimental rocket engine test station at Muroc, California.
It changed somewhat in 1949 on January 17th, was the first meeting of the Technical Advisory Board, called TAP.
In a short while, we found out that our facilities at Azusa, due to the testing we were doing, and occasionally malfunctions, either intentional or otherwise, causing explosions, detonations, so forth, made it a little difficult for us to continue some of this work at Azusa.
I think it was Ken Munt, since he came from Sacramento, that suggested looking at this site right here. Was far and away the best. We had the land, the water, the necessary isolation combined with the requisite accessibility, power. So we built what was known as the Sacramento Solid Rocket Plant.
I think one of the most permanent impressions that I ever have was the tremendous trouble that occurred when we tried to put the JATO, the present 15KS-1000, into production at Sacramento.
The 15KS-1000 JATO, developed at Azusa, simply wouldn't work when production moved north. Solve our problems we did, and the Sacramento Solid Rocket Plant was underway. Later, Aerojet General entered into an Air Force competition for the engines for the backup Atlas program, which later became the Titan program. The first 20 years haven't been all technical problems and management considerations. Who can ever forget Ernie Roberts, framed by a blown-out window, the latest thing in starched collars? Or our top executives, including Andy Haley, then president, and Eddie Behan, then general manager, in gloves and coveralls, cleaning, loading, painting, and shipping the early JATOs on an all-night swing shift that lasted for weeks. Some of the early conversations the military had with us were really very amusing.
But as we started with the first contract, which was $10,000, I believe, where I could employ and pay this boy for their work, General Shidlaw, who is now a retired general with 4 stars, and I think president or vice president of Thomson's product, looked at me and said, "Doctor, you really believe that the Air Force shall spend as much as $10,000 for rockets?"
We asked Dr. Roberts, Mr. Ross, and Mr. Kimball to exercise their point of view on the subject.
First, the JATO contract, and second, I think, the Polaris contract. Very soon we had, of course, the Minuteman contract, which...
As I recall, around 1946, there was a sudden requirement for the B-29 to carry, I believe, 150,000, somewhere around 148, 150,000 gross payload. So it appeared that the only answer was to build a small pressurized unit of some 4,000 pounds thrust, as I recall, of which then the B-29 was to use 2 of these, and they were attached between the engine nacelles. And although the requirement for the use of it disappeared after a couple of years, it was actually judged to be probably the first really operational liquid engine. From there, we went into competition with the then and probably still significant people in the liquid engine business for the development of the acid gasoline assist takeoff units for the B-47. And then the same engine series worked into the F-84 assist takeoff, and a fourth unit was the in-flight thrust augmentation unit for the F-86, which also was very successfully flight tested. The group that I mentioned stayed with this program, and of course they were the key people that put together and won the competition in the early or the middle 50s for the Titan engine, which is now quite a significant effort at Aerojet.
Of course, I'm sure that the first contract we got was the production contract on the old asphalt JATO. In addition to that contract, and that's the one we remember, of course, the contracts that we've gotten in later years have been great pride to all of us. Our Polaris, our Minuteman, our Titan, lately our Rover contract, and our contract for the M1, which is a 1,200,000-pound liquid hydrogen engine.
Time magazine has called Aerojet the General Motors of U.S. rocketry.
I believe that the space flight, and in connection with that rocketry, first has for several years or decades a great importance for military purpose. Even if we don't want to make war, and we really don't, you must do this to be sure that nobody else does it. Immediate applications I see are the following. First, the weather satellites. Whether a weather control is possible, then I think that the communication can be improved very much by introduction of a satellite system.
Aerojet General Corporation, 1962, past, present,